Hey everybody, Chris Dingman here, superhero name, the Math and Science Explainerator, Adorator. This video covers the standard form of quadratic functions, and you can watch this video on its own, but it's also the third video in my series on quadratic functions and parabolas. So if you want to watch this series in order, which I recommend, the video to watch before this one is the vertex form of quadratic functions. All right, so we've been talking about quadratic functions and parabolas. So a function is an equation like this one, where you have an input and an output. And a quadratic function is a particular kind of function where the highest power of the x is 2. And we've been talking about how quadratic functions, when you put in various inputs and get out various outputs, you get coordinates that form shapes we call parabolas. And we talked about a particular form that you can put a quadratic equation in that allows you to see numbers that tell you something very directly about the parabola that you're going to get. We talked about this form called vertex form here in the green circle, and that's a really helpful form because you can read the vertex of the parabola right from the equation, and you can tell whether it's facing up or down and how wide it is compared to what we call the parent graph, or the simplest version of a quadratic or parabola. So the vertex form here, y equals a x minus h all squared plus k. That a value out front is what I was just talking about, the up, down, and narrow or wide. The minus h is an indication that the x coordinate of the vertex is the opposite of this number here, which in this case is a +2. And then plus k is the straightforward y coordinate of the vertex. And I've rewritten this equation in vertex form slightly differently right below here, where instead of a +2, I write that as minus a -2. So now it's exactly in vertex form where the negative matches up, and you can clearly see that h has to be -2. So it looks like a +2 when it's simplified up here, but it's really a -2 for the x-coordinate of the vertex. So this particular quadratic makes a parabola with a vertex at -2, +1, and it faces down because it's the -1/4 out front, and it's wider than the parent graph because 1/4 is less than 1. Now we're going to talk about a different form that I could write this quadratic in, called standard form. So we're going to go there by looking at an example starting in vertex form and transforming it into standard form. All right, so let's clear the deck and start on this example. Let's say we had this quadratic in vertex form. Let's change the way that thing looks. And the way we're going to do that is we're going to multiply x plus 3 times itself, because that's what that square is telling us. It's saying take x plus 3 and multiply it by itself. So here we go. All right, now when you multiply two things in parentheses like this, you have to multiply everything in the first parentheses by everything in the second parentheses. So that's going to be x times x. That's going to be x times 3. Then it's going to be the next thing. It's going to be 3 times x and 3 times 3. So notice what that meant in this case was I multiplied the first terms, that x times x. So I'm going to put an f for first terms. Then I multiplied the outside terms. That was the x times the 3. So I'm going to say O for outside. Then I multiplied the inside terms, I for inside, and then I multiplied the last terms, so L for last. So when you're multiplying two what are called binomials, x plus 3 and x plus 3, sometimes we call that foiling. But really, it's just multiplying everything in the first parentheses times everything in the second parentheses. Okay, so if we do that multiplication out, we're going to get 1/3 x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And then the -7. All right, and now we're going to just combine some like terms here, because 3x plus 3x is 6x. So we're going to have x squared plus 6x plus 9 minus 7. All right, and then jumping over here to the right, we're going to distribute that -1/3. We're going to multiply it by everything in there. And when we do that, we're going to get y equals 1/3 x squared. Okay, 1/3 times 6 is 2, so 2x. 1/3 times 9 is 3, so 3, minus 7. Okay, now we have some more like terms. We have 3 minus 7. So let's do our final simplification here of 1/3 x squared plus 2x minus 4. 3 minus 7. We call this form of the quadratic the standard form. Standard form is written like this. It's y equals some number times x squared, usually that's called a, plus some number, usually called b, times x, and plus some numbers, usually called c. So this is what we call standard form. So I haven't changed the quadratic equation or the parabola. I've just rewritten it in a different form, right? This is the same quadratic as this, and it'll make, of course, the same parabola. And I want you to notice what happened to these helpful numbers over here in vertex form. In vertex form, we could look right at that and say it's a vertex of -3 and -7. And we could see that it's facing up because it's a positive 1/3 out front, and it's wide because it's a number less than 1. It's 1/3. Now, we actually still see the 1/3 over here in standard form, and that's why this a is still used in standard form. Notice this a and that a. They're the same a. So we still have that information in standard form. We still have the information a, which tells us about the width of the parabola and whether it's facing up or down. So that's great. But the other numbers, the vertex, the -3 and -7, they're gone. We have a 2 and a -4. What the heck do 2 and -4 mean, if anything? Well, I would say that standard form is less helpful if you want to picture the parabola than vertex form. Now, it does give us some information. We already know it gives us that a. Let's see what else it gives us. All right, so here we are with the vertex form for a quadratic and the standard form for a quadratic. And then underneath those general forms, we have in orange 2 versions of the exact same quadratic. So obviously they're going to make the same parabola. So let's draw an axis. And let's say we only were looking at this standard form here, 1/3 x squared plus 2x minus 4. So again, we know about the 1/3, that's the a. Let's make a quick table of values. And before you panic about me doing all sorts of points, I'm only going to do one, I think. I'm going to put in 0 for x. Nice and easy. Input a 0 for x, what happens? All right, -4. Notice that -4 is this number hanging off the end there, the one without an x, because all the ones with x's, all the terms with x's, turn into zeros, and y is just that number hanging off the edge. So let's plot that point. That point is 0, -4, so 0 down 4. So here we are. We know that the parabola goes through that point. And that is what we call a y-intercept. It's where the parabola is going to intercept the y-axis. So if we were only looking at this standard form, we would know that the parabola has to cross at that point, it has to cross the y-axis at -4, And we'd also know it faces up because the 1/3's positive and it's kind of wide. So I wouldn't really know where the parabola was besides that information. It could be here, kind of a wide parabola facing up, or it could be here, again, wide parabola facing up, crossing that point. So standard form gives us the y-intercept. But if we could put it into vertex form, now we're in better shape because we can quickly see that this parabola has a vertex at -3, -7. So back 3, down 7, I'm going to say that's about right here. And we know that it looks like this. And let me just label that point, that y-intercept. Input a 0 for x, we output a -4 for y. So standard form gives us up or down, wide or narrow with this a value out front, and it gives us the y-intercept, which is the number hanging off the end with no x in it. The c value, right? That corresponds to the c value. What about that b, which in this case is a 2? Does that tell us anything directly about the parabola? No, not directly. However, it is part of a little magic formula that I'm going to show you here. And I'm not going to show you why this formula works in this particular video, but I'm just going to show it to you as a way of finding what we call the axis of symmetry of a parabola, as well as the vertex. So here's the little magic formula. The x-coordinate of the vertex is going to be -b over 2a. So x-coordinate of the vertex is -b over 2a. It's better if I call that the opposite of b instead of -b, because if b is already negative, then I'm going to have the opposite of a negative number, which would turn out positive. So I should have said the opposite of b over 2a. All right, so in this case, b is 2, except we want the opposite of that. And then 2a is 2 times 1/3, so 2 times 1/3. So now we're going to have -2 over 2/3, and that's -2 divided by 2/3, which is the same as -2 times the reciprocal, which is 3/2, because dividing by a number is the same as multiplying by the number's reciprocal. So look at that, my 2's cancel, and I'm going to just get -3. -3, that's the x-coordinate of the vertex. But we already knew that right up here, because we had the vertex form. So notice, even if you don't have the vertex form, if you use this handy magic formula, you can get the x-coordinate of the vertex. So back 1, 2, 3, Now, if you didn't know that the y-coordinate was -7, what would you do? Pretend you're just looking at this standard form. Well, it's simple. You just put that number in for x. You input a -3, right? Because that's the x value. We know that's the x value of the vertex. So we input that into the equation, and the equation will spit out the y value for that x value. So we would plug that in. And there's our -7. Now, I mentioned something a minute ago called the axis of symmetry. So axis, just think of that as a line, and the word symmetry is same on either side. So the axis of symmetry is just a line that you can draw through the parabola that cuts it symmetrically in half. So that is going to be vertical for our parabolas. That line's always vertical. And you can see it's going right through -3 in this case. So let's move -3 off to the side. And let's draw a vertical line right through -3. In other words, let's draw our axis of symmetry. All right, there it is. Now, the equation of that line is x equals -3. The equation of any vertical line is going to be x equals some number. It's going to be x equals whatever number the line is going through. So it can throw people a little bit because we think of vertical as y, because the y-axis is vertical. But when you have a vertical line, its equation is x equals whatever number it goes through. And that's because any point on that vertical line has an x coordinate of -3. Okay, so here's the equation for the axis of symmetry for this particular parabola. And as I said before, that's also the x coordinate of the vertex. Okay, so the equation of the axis of symmetry is going to be x equals some number, in this case -3, and that number is also the x coordinate of the vertex. So let's move our handy dandy formula x equals -b over 2a over by the standard form of the equation, which is the form that your equation needs to be in if you're going to use that -b over 2a. All right, let's look at another example where we start with a quadratic in vertex form and transform it into standard form and then figure out what it looks like from there. So let's say we had a quadratic in vertex form that looked like this. And let's transform that into standard form. And the way we did that was we first squared this x minus 1, the thing in parentheses. So that looks like this. X minus 1 times itself. Then we FOILed, so to speak, the x minus 1 times the x minus 1. And that was multiplying everything in the first times everything in the second. So this times this, this times this, this times this, and this times this. And that gives us this. All right, then we combine these x's as like terms in the parentheses here. Now we distribute the -2. And now we just combine these two numbers at the end. And there's our parabola or quadratic in standard form. So I'm going to write it up here with standard form right underneath it. So we can see that in this case, a is -2, b is 4, and c is 2. So remember, the things we can say right away looking at a quadratic in standard form is that the a tells us up or down, narrow or wide. In this case, we have a -2 as our a value. So this thing is facing down, and 2 is bigger than 1, so it's more narrow than the, quote, standard parabola. So we know it's narrow or narrowish and facing down. And then that last number, c, which in this case is also a 2, but a +2, that tells us the y-intercept, right? Because, again, if we made a table of values and plugged in 0 for x, this would become a 0, this would become a 0, and we just get an output of 2. So let's make a little table of values. Input a 0, output a 2, 0, 2 is a point. Here it is. Boom. So we know it hits that point and it's narrow and facing down. So if that's all we knew, we wouldn't know if it looked like this or something like that. But we have our axis of symmetry formula. All right, so in this case, that's going to give us x equals the opposite of b. In this case, b was 4, so the opposite of 4 over 2 times a. And a was a -2, so be careful there. And x is -4 over -4, which is 1. So the axis of symmetry is 1. And remember, the equation of that is going to just be x equals 1. But that's also the x-coordinate of the vertex. How do you get the y-coordinate? Just plug that x-coordinate back in and see what you get for y. So I'll rewrite this quadratic up top and plug in a 1 for x. So that's going to be inputting a 1 down here in our table of values, and we're going to see what we get for y. Just rewrote the equation. Now I'm going to plug in 1. Well, look at that. We got a 4, which we already knew was going to be the y-coordinate of the vertex because we started in vertex form and saw that 4. But we're pretending we didn't know, and so now we do. X is 1, outputs y of 4, and we know that's going to be our vertex. So over 1 up 4, that's up here. So one more form for parabolas or quadratics to look at now, and that's going to be the x-intercept form. So let's see how we get there and what it tells us. All right, that's the video. I tutor math and science online. Check out my website given here. And if you're watching this video in my series on quadratic functions and parabolas, the next video to go to is x-intercept form of quadratics. All right, see you there.